Okay, the last one. Let's share. Okay. To graph y equals x subtract 4 squared, you shift the graph of y equals x squared to the, since it's subtract and it's on the inside, that is a shift to the right. Be sure you have that paper. A distance of 4 units. Joy. All right. Just like what we did in the last section, what's what we're going to do here. So first, what is that graph? It is x squared. What's wrong with it? It has been shifted down 5 units. So that would be a subtract 5 outside. So our new graph is x squared subtract 5. That one's not bad because it's just subtract 5. I had to make sure I didn't grab the negative one. Here we're going to have x squared again. I think they're all x squared, honestly. And then what's wrong with it? It's upside down. And down 2 units. So let's rewrite it. And I guess this one's not bad either. So negative x squared subtract 2. Okay, x squared and this one went right 2 units. So this one, when we rewrite it, this is when we actually get to do the stuff. We'd have x subtract 2 squared. But that's not an option because they want us to multiply this out. So we'd have to FOIL it out. Which would give us x squared subtract 2x subtract 2x, and a negative 2 times the negative 2 would be plus 4. And then we'd combine our like terms right here to get x squared subtract 4x plus 4. So that's all that changes in this lesson, is that we're now moving to this step instead of leaving it like this. They want us to multiply it out. So this one, since it's x squared but it's been shifted left 2 units, we would have x plus 2 squared, which would give us the x plus 2 times x plus 2 here. And if we multiplied it out, we'd have x squared plus 2x plus 2x, and positive times positive is positive, plus 4, which would be x squared plus 4x plus 4. Right. Now this one, I wish I could make that menu go away. Is going to be right 2 up 2 up 2 right 2 up 2. So if we wrote that out without multiplying it out, we would have x subtract 2 squared, and that's our right 2, which is the same as right here. And then that up 2 on the end would give us plus 2. So when we multiply that out, it's going to be the same as this right here. So I'm going to go ahead and x squared subtract 4x plus 4. But we still have this plus 2 right here. So plus 2, which is going to leave us with x squared subtract 4x plus 6, because that 4 plus 2. This one went left 2 down 4, so we'd be subtracting 4 from this one. And I'm going to go ahead and just get through with these so we can move on. This one, since it was the right 2 one, it would have been the subtract 4x, and then when we subtract the 4, and then here's our last one. Do y'all see what I did? I typed this one out, and I didn't put the right one because I have this one. So my right should be negative and my left should be positive. So let's just swap them. I wrote it right. That's one of the things too when you take this test. Show your work, because if I saw that, I'd give you full credit. Okay, so our graph is x squared. It's 2/3 x squared. So x squared is a parabola. Doesn't matter where you click, it'll put it at 0. Since it's 2/3 and it's being multiplied by it, we know that's going to be a vertical stretch or compression. This is the only one you have to do this on. And I remember the first time I did it, I wanted to put the 2 here and the 3 over here. It don't like that. So when you type the fraction in here, because the fraction bar don't show up like the little table you've been using, backslash. You have to use a backslash to get it. Okay. Graph the function f of x equals x plus 2 squared, subtract 2. This should be one we literally just did. Okay. Start by using the graphs. So click to enlarge our graph. It's x squared. They have x squared already clicked, so I'm going to click it. Plus 2, since it's on the inside, it's the opposite, so we go, it's bouncing all over the place. Left 2, and then down 2 would drop us down to negative 2. That was really it? Okay. Graph the function f by starting with the graph of y equals x squared and using the transformation shifting, compressing, stretching, and or reflecting. Write in the form f a times x subtract h squared plus k. Okay, so our function is There's a couple things I can tell you from this graph if you've been paying attention. Since there's a plus sign right here, I know that this graph went left. So horizontally shifted right, no, left, yes, right, no. So it's not A or C. I know that already. And then I know it's D. Without completing the square, I know it's D. You can do this by completing the square as well, though. But whatever direction it went, remember it'd be doubled right here because we square it. So 3 plus 3 is 6. 5 plus 5 is 10. It's not that. And then I can check that it was shifted down 5 because this last number should be 3 squared, which is 9. But 9 subtract 5 gives us that 4. Okay, if we were to complete the square, though, we would have this set equal to 0. This is going to suck typing it on here. Okay. I'm just rewriting it, and I'm going to make it equal to 0 first. And then I would move my 4. All right, now then I would rewrite it. But since we are completing the square, I'm going to leave room for my completed square value. That would go on both sides because anything you add on one side of an equation goes to the other, and it's always going to be plus. Because even if it was a negative value, a negative squared is positive. So once we have this wrote out, we take that 6 and we divide it by 2 because I know that that value is half of whatever was squared to find it. So 6 divided by 2 would give us our 3, which I told y'all was going to be there. And then whatever this value is, we square it to put in these two places. Okay, now we're going to rewrite our equation with what we found. So I'm going to have my x squared and this 3 squared, and I'm going to put them together. This is a positive 3, so I'm going to have and then I'm going to look over here. Everything right here is this, because if I FOILed this out, x times x is x squared, 3x plus 3x is 6x, and 3 times 3 is 9. And then on this side, I'd have 9 subtract 4, so it did equal 5. But whenever we move something to the other side of the equal sign, we change the sign. So this is our equation back to how we've been looking at them. So we went to the left 3 and down 5. Right. Then when we graph this, it's a square, so it doesn't matter, but we go down 5 and left 3, so negative 3. New one. So they have x squared. Whew, that's awful. Plus 8x plus 15. So if we're doing what we did a moment ago, instead of working it completely out using completing the square, I know whatever this is, it's half of it. And it's actually the same thing. I guess I'm just doing it in my head. So I take half of my 8 because I know that this value got doubled to get it. So I know That would be a positive because it's not a negative number squared. So I know I'm going left 4. Now then, 4 squared would have been 16. So since this is not 16, it's less 1. I know they subtracted 1. So I want to type instead right now. So they went left 4, down 1. Now we can graph that. Click anywhere. They went left 4, down 1. Negative x squared plus 8. We have that negative at the front. I know I'm going to move 4. That don't look like a 4. I know that my graph is upside down because that negative. That negative also makes me think that this should have been a subtract, but let's see. The graph should be horizontally shifted. We need it to be reflected about the x-axis though, because the negative's out front, so it's going to be CRD on that one. I'm betting we're going to go right. And then if we would have had out here, that one's saying up 16. I need to explain this. What did I do in my head? What did I do? I knew right. I guess that's it. Because I knew it had to be reflected about the x-axis and go right because I had to subtract here. And this one was reflected about the x-axis and went left. I'm sorry. So we reflect about the x-axis. Check. And then we went right 4. And then we went up 16. When you graph that one, be sure you reflect first. All right. On this one, you do not have to type it out, I'm pretty sure. So don't make it harder than it has to be. So it's a negative x plus 2 squared plus 2. Because I know I have this point, and this point is at my vertex. So left, up, and it's upside down, and it's an x squared, so I know it's a negative x plus 2 squared plus 2. Let's see if it takes it that way or if it wants us multiplied out. It's good. Okay. If y'all get stuck, email me, because I failed at explaining that one horribly bad. Have mercy on me.